Hello everyone. So in this video, we're going to study about the design methodology. So there are 9 steps in total, and we'll be seeing each step one by one as we go further into the deck. Let's just start with the first that says identify a problem to solve. Before you jump into building the blockchain, let's just pause and just ask yourself a question. Do you actually need blockchain? The design methodology begins with, being brutally honest with yourself and your business challenges and clearly define the pain points. Right now, in your current system, what's broken, what's inefficient, and what's untrustworthy. Then hold all these challenges up against the blockchain's high level use cases, let's say decentralization, immutability, security, and then see if they actually align up with the needs or if you're just chasing the hype. Then comes the reality check of this, that whether or even should you actually go with the blockchain, because sometimes a well defined database or sometimes a cloud solution could actually be faster, could actually be more cheaper for your problems. And blockchain, I believe, should only step in when its unique properties are giving you a clear edge. Finally, if the blockchain is actually making sense, you will need to decide, do you migrate your existing system in the blockchain based model, or should you build something entirely new from scratch? So the first step is all about strategy. It's not about how we can use blockchain or whether or not we should be using blockchain. And trust me, if you ask that question early to yourself, you're going to separate yourself from actually the unsuccessful blockchain projects that are left in between. Then coming to drafting your business requirements. Once you now confirm that blockchain is the right tool, the next step is to draft your business requirements. And this is where the clarity is going to make all the difference. Start by defining your functional, your non-functional, your technical needs in detail. What exactly should the solution do? What features for you are non-negotiable and what features are just add-ons? And then identify which parts of your system should be on chain. That is where you need transparency, you need immutability, you need decentralization. And then which parts are okay to remain off chain, that is in external systems or in databases where you need scalability, where you need flexibility. And from there, just create a product roadmap. Now product roadmap does not only have to deal with your deadlines, it should also be taking care of your resources, your responsibilities, your timelines, so that the project is moving in a very well structured manner. And finally, ensure that nothing should slip out of the cracks. Every business process, every integration, every compliance need should be covered at this stage. Because if you overlook all these requirements in this stage, you're going to pay a heavier price for it later. So in short, this stage is all about turning your vision into structure, defining everything you need to do, and how are you going to do. Then coming to the consensus mechanism. Now that everything is mapped out, your business requirements, now the decision comes to you is how will your blockchain network actually agree on what's true. Because once you've appended a block to the chain, you cannot make any amendments to it, you cannot delete that block. So now you have to decide which consensus mechanism are you going to choose, because consensus is the only thing that is going to have you manage things in your decentralized system. Because in decentralized system, we all know no one's in charge. So if you want to maintain agreement, you want to maintain security, you need to choose a consensus mechanism that is aligning with your needs. And there is no one size fits all approach. We have different mechanisms, and choosing them is actually the point of this step. So you have proof of work. You remember it was secure but energy intensive. Then you saw proof of stake also, which was energy efficient, and it also rewarded your long-term participants. Then you have Byzantine fault tolerance, BFT, which is designed to handle malicious nodes. Then you have your deposit-based consensus, where stake deposits secure the system. Then you have your proof of elapsed time that focuses on fairness by using time-based selection. We'll be talking about them in detail one by one after, at a later stage. And right now, what we should think is that choosing between them, it is going to depend on your business needs, your network size, your security goals. A financial network, if you're building a financial network, you might demand something that has maximum security. While if you're doing something with supply chains, you might want something that is faster, that is scalable. So the key here is evaluation. The right consensus mechanism is going to ensure that your blockchain doesn't just run, it runs in a way that is going to align perfectly with your application's purpose. Then coming to the next step, it is choosing the best blockchain platform. Now that you've identified your requirements, you've chosen a consensus mechanism, the next big decision is which platform to build on. And this choice, trust me, can make or break your project. And now you'll be thinking, why? But why are you saying this, Cherish? Because your platform is going to directly impact your cost, directly impact your scalability, directly impact what skill set you have, what timelines you're going to meet with all these given things. In other words, it is going to shape your budget and your speed to the market. So, when evaluating platforms, please keep 5 key criteria in your mind, starting with the first that goes with problem fit. You need to see that the platform you're choosing, is it actually going to solve the challenge that you've already identified in the earlier steps? Then consensus compatibility, since you've already chosen a consensus that is going to fit with your needs, is it supporting the mechanism? Then coming to cost and resources, where you're going to see about the infrastructure, licenses, transaction fees that you're going to face. Then coming to the skill set, does your team have the expertise to build here in the in the platform that you're choosing? And the timeline, that how quickly can you launch? What are your expected timelines? So some of the most popular choices today include Ethereum, and Ethereum is for smart contracts and decentralized apps. People use Hyperledger Fabric for enterprise grade solutions, Corda for financial and regulated industries, and Polygon for scalability with lower transaction costs. The takeaway is simple. Don't just follow hype. Consider your case and think what is aligning best with it. So, you have to pick a platform that is aligning with your business needs, it is aligning with your technical needs, and also your long term vision. Coming to the next, then you have to design your blockchain nodes. Now that you've chosen your platform, you've taken care of consensus, the next step is about shaping the architecture of your blockchain network. And this is where, some of the most fundamental choices you need to make, like whether your blockchain system is going to be permissionless, that is like Bitcoin, Ethereum, open to anyone, or you're going to work on a permission network like Hyperledger where access is controlled. And once you've chosen this, you'll be able to make the choice of your blockchain, whether it's going to be public, private, or hybrid model, depending on how much transparency or how much confidentiality you want to give to your to your business stakeholders. Next comes node deployment. Do you want your blockchain nodes to be on cloud, or do you want them to be on premises, or do you want a hybrid model for balance? Then it's the time to set the developer foundation. That means selecting your programming language. For example, you can go with Solidity, you can go with Go, you can go with Java. Your operating system, you can go with Ubuntu, you can go with Windows, you can go with Red Hat, you can go with Debian, CentOS. Every decision here should align with your business objectives, your resources, and your budget. In short, your architectural choices define not only how your blockchain performs today, but also how it is going to scale for tomorrow. Then let's see your next, that is plan your blockchain configuration. When building a blockchain solution, it's not just about consensus, it's not just about the platform. You also need to be very careful about the configuration of the finer details of how your network is going to operate. This includes setting up permissions, who can do what on the network, along with the rules for, let's say, for the asset issuance, asset reissuance, that defines how your tokens or how your digital assets are going to be created and managed. Then you're also needing to be considering your atomic exchanges for secure trustless asset swaps and strong key management to protect access. Then you have features like multi signatures, where you add in an extra layer of security, telling that, okay, I will need multiple approval before telling a transaction to be valid. On the technical side, we have other things like parameters, native access, address formats, key formats, block signatures, handshaking. So what the important part is, while some of these you can actually modify the runtime, but it's always best to plan ahead and early. Thoughtful configuration ensures smoother development, stronger security, and a blockchain that runs reliably in the long term. So all these permissions you need to take care of, you need to assign them, you need to take care of them well in advance. Then coming to the API part, when developing a blockchain solution, you'll often interact with it through the API, through your application programming interfaces. Think of API as just a bridge between your application and the blockchain network. Some blockchain platforms come with built-in APIs, while some want you to have a custom API development done. So the most common API functions are going to include key pair and address generation for identity and access, audit and compliance operations to ensure regulatory standards are met, data authentication using digital signatures and hashes to verify integrity, data storage and retrieval so applications can read and write to the blockchain, smart asset lifecycle management that covers creation, transfer, and retirement of assets, and of course smart contract interactions, which lets your applications execute logic on the blockchain seamlessly. So a well-designed API is going to ensure secure, efficient communication within the blockchain. It's like having secure doorways into your blockchain, which is going to ensure that communication between your system and the blockchain is both efficient and secure at the same time. Then designing the UI part. Whenever somebody is going to think of blockchain, they're going to picture it like some complex cryptography, some complex consensus algorithms, nodes talking to each other, how and what, don't know. But let's be honest, for the end user, it's all about what they see, what they feel about it, right? None of this is going to matter unless they can interact with it easily. And that's what is the role of the user interface, the UI part. Designing the UI is about creating visual layouts, interactive elements that make blockchain technology usable, that make it intuitive. The UI must integrate smoothly with the backend APIs, ensuring that whatever the user sees and does on the screen actually connects with the blockchain in the real time. The tricky part is blockchain processes can be highly technical, highly overwhelming. So if there is a great UI, you've already bridged that gap. You've already balanced your aesthetic appeal with the technical functionality. The goal still stays simple. You have to hide the complexity and present the power of blockchain in a way that's friendly, that's clear, that's effortless for its users. In short, the best blockchain UI turns complicated cryptography into a simple button click. Right? Then coming to the last step, there is a step 9 of choosing an accelerator to optimize your blockchain application. So, when the blockchains grow, the pressure on the performances also grow. They have to validate thousands of transactions, manage governance, store massive amounts of data, and this can actually overwhelm standard setup. So that is why we have accelerators in place. Think of them as just the turbochargers for your blockchain. They are specialized hardware that are designed to handle compute intensive tasks far more efficiently than the general purpose machines. And how do they do that? They offload the works like transaction validation, data storage, governance functions, and they're going to distribute that load, taking them off the chain, which is going to give you faster processing, higher throughput, and the benefits are not going to stop at speed. Accelerators can also improve your power efficiency, they can also give you flexibility, and this becomes crucial when you're scaling a blockchain application for real world high performance use. So if you want your blockchain solution to move from experimental to enterprise grade, hardware accelerators don't just become optional, then they become a necessity of the art then. Right? So they are so essential. And then with this, if you have any concerns, if you have any doubts, please post them in the comment section. If you want me to take a concept, if you want me to take a subject next, or if you want a one-on-one, just go down and you can see the G form there in the description. And if you could extract 10%, 20% of the video, if you thought at the time that, okay, this video is helping me, then just go subscribe, like. Yeah, thank you so much. Bye bye.